Hi everyone, welcome to this session. We are discussing about current divider rule. Current divider rule is about resistors connected in series, and we're going to ascertain the level of the current that is going to flow across each junction or across each resistor, because whenever two resistors are connected in parallel, current is going to split at the junction. So we're going to use Kirchhoff's current law to ensure that whenever current reaches a junction, it splits into various components. So we're going to derive a general expression that will assist us to calculate the current that is flowing at any junction, So what we do, we'll get the total resistance for these two resistors connected in parallel. We'll use a special case where when two resistors are connected in parallel, we take the product over some method. So the total resistance will be equal to R1 multiplied by R2 divided by R1 plus R2. That is the total resistance in the circuit. We'll again get the total voltage. The total voltage in the circuit will be given by the total current IT multiplied by the total resistance RT. This will be equal to the total current. The total current is given as IT. The total resistance is given as R1, R2 divided by R1 plus R2. So once you get this is the total voltage. That is the total voltage in the circuit. And we know for when resistors are connected in parallel, the voltage across the resistors is the same. Very important to note that in a parallel connection, voltage is the same, meaning this voltage here will be flowing at this point and at this point. From Ohm's law, we know that current is equal to the voltage over resistance. That is from Ohm's law. So we want to get I1. I1 will be given by the voltage, the total voltage, divided by the resistance, divided by R1. Remember, the total voltage, the expression we are using for the total voltage is this. So it means it will be 1 over R1 multiplied by this V, which is IT into R1, R2 divided by R1 plus R2. So that is what we get. Once you do this, if you cross multiply, remember this R1 will cancel with this R1. So that now we will say I1 will be equal to R2 divided by R1 plus R2 multiplied by I total, multiplied by the total current. That is our first current. We have gotten I1. We will now move to I2. Remember, I2 will be given by the total voltage, which is this. Remember, we have said current I2 is equal to V all over R2. We want to get the current flowing here. So it will be equal to the total voltage in the circuit is given as, remember this is the total voltage, it means we will be having 1 over R2. And then we have IT into brackets R1, R2 all over R1 plus R2. Remember what we have done? We have replaced this V in this particular equation. And by doing this resistor and this resistor will cancel. So that now our I2 will be equal to R1 all over R1 plus R2 multiplied by the total current, you will be able to get that value. You will be able to get this value. So it is very clear. If you analyze this situation, if you want to get I1, we are using R2 over the total fraction. So if you want to get the current flowing in the first branch, you use the resistance of the second branch. If you want to get the current in the second branch, I2, you'll use the resistor in the first branch. So it is alternate. If you want to get the current here, you use this resistance over the total. But if you want to get the current here, you use this second resistor over the total resistance. So that is what is called current divider rule. We want to move ahead and solve one example where we shall apply that. Remember, I've said that if you want to get the current in the first branch, then you need to use the resistance in the second branch. So we want to look at an example very fast. The example reads, two resistors, which is 6 ohms and 3 ohms, are connected in parallel. Later on, they are connected in series to a 4 ohm resistor and a cell of 1.5. You find the total resistance. So that means you have been told two resistors are connected in parallel. The two resistors are these. They are connected in parallel. And then they are connected in series. So it is always important for a student to draw a circuit. To help understand the concept. So the first resistor is 6 ohms. We have 3 ohms. And we have 4 ohms. Those are the resistors. We have been told the 6 ohm, the 3 ohm are connected in parallel, but the two combinations, the combination is connected in series to a 4 ohm. We have been told the voltage here is 1.5 volts. Now the question requires us to get the resistance. We can say this is our R1. Let us say this is our R2, and let us say this is our R3. Resistor 3. So if you want to, the best way to solve this question, the best way to solve that question is by simplifying that circuit. You simplify that circuit, whereby you start by reducing this circuit. The two resistors are connected in parallel. So we would say R, let us say RT will be equal to, or let us just call it R, will be equal to R1, R2, R1 plus R2. We want to simplify that part, will be equal to 6 times 3 all over 6 plus 3. This is 18 divided by 9. So our R will be equal to 2 ohms. After you simplify that, our circuit reduces to this point. Remember, this is our R, which is 2 ohms, and we have said this is our R3, which is equal to, this is our R3, which is equal to 4 ohms. We have only simplified this part. This is 2 ohms. We know when two resistors are connected in series, we sum. So the total resistance RT will be equal to 2 plus 4, which is equal to 6 ohms. So we have now gotten the total resistance in the circuit. We have answered the first question, the total resistance in the circuit. So what I've done, I have gotten an equivalent resistance for the two resistors connected in parallel. Later on, I've written this circuit, I've drawn this circuit. Then the next step will be now combining the two resistors connected in series. You get 6 ohm. We have answered the first question. We will now move on to answer question B. Remember, this was our question A. Question B will be current and voltage across each branch. Current across each branch. We have said that when current when the current will be flowing in this circuit, will flow from the source, reaches this point, it will divide. Another very important point you need to know is, in a series connection, current is the same. In a series connection, current is the same. So what we shall do is this. We know, if you want to get this, let us say this is our I1, this is our I2, and this is I3. So I1, how do we get I1? The first thing you will have to get is to get the total current in the circuit. You will have to get the total current in the circuit. The total current in the circuit, IT will be given by V over RT, which will be equal to the total voltage in the circuit is 1.5. The total resistance in the circuit is 6. So if you take 1.5 divided by 6, 1.5 divided by 6, divided by 6, you divide by 6, you will get 0.25 amperes. That is the total current that is flowing in the circuit. The total current that is flowing in the circuit. Secondly, the second thing you will do is this. You will now take the current flowing I1. I1 will be equal to, remember, if you want to get I1, you use this resistor. It will be equal to, I1 will be equal to R2 all over R1 plus R2 multiplied by IT. That is what we have said, if you can remember. So that you have the resistance 1, the first resistor there is, we have 3 divided by 3 plus 6 multiplied by the total current 0.25. This will be equal to 3 over 9 divided by 2.5. Remember this 3 over 9? So 3 over 9 is 1 over 3 divided by, so you divide by 3, you will get 0.0833 amperes. That is our I1. If you want to get I2, it will be the same as, now you will use this. You will take 6 divided by 6 plus 3 multiplied by 0.25. 0.25. So 0. This is, remember, this is 6 divided by 9. 6 divided by 9 times 0.25. 0.25, remember, you will get here 0.167 amperes. That is your I2. Another important point you need to know, I3 will be equal to 0.25, the original current. Remember, they are connected in series. This current, upon reaching this junction, it will split into 2. So I2 will flow here, I1 will flow here. Then, at this particular point, I2 and I1 will combine here. So if you combine this plus this, you will get 0.25. So I'm saying I3 is the same as I1 plus I2, which will be equal to 0.083 plus 0.167. So this will give us 0.25 amperes. So the total current is the same as the current flowing across that particular point. So we have said 0.25 amperes is our I3. Remember, the next question we have been asked is to get the voltage across each resistor. Voltage across each resistor. It is very easy, because what you need to do is to, we know from Ohm's law, voltage is equal to current times resistance. So if you want to get, let us assume this V1. V1 will be equal to I1 R1, which will be equal to, remember, our I1 is 0.083 multiplied by, you multiply by the resistance, which is 6. If you take if you take that one times 3, if you take 0.0833 times 6, you will get this one to be 0.4998, which is roughly 0.5 volts. So the current across V1, this V1 will be that. If you want to get V2, V2 will be equal to I2, R2. Remember, this will be 0.167 multiplied by 3. If you take 0.167 multiplied by 3, you will get 0.5 volts. 0.5 volts. And now you can see V1 is equal to V2 because they are connected in parallel and they are sharing the voltage. If you want to get V3, you take I3 multiplied by R3, which will be equal to, remember our I3, our I3 is 0.25 multiplied by the resistance, which is 4. Remember, that gives you 1 volt. 1 volt. And if you check clearly, the voltage dropped by this plus the voltage dropped by this will be the same as the voltage from the source. Remember, this combination drops 0.5, this one drops 1, and the total sums up to 1.5. So the total resistance or the total voltage is 1.